Hello, hi, my name is Anas Zahiri bin Zulkifli. I'm from Robotic and Automation Year 1 student. So today, me and my team will present about the first law of thermodynamics. So what is the first law of thermodynamics? So the first law of thermodynamics is a formulation of the law of conservation of energy in the context of thermodynamic processes. The law distinguishes two principles form of energy transfer, which mean heat and thermodynamics. The modifier of thermodynamic system containing the constant amount of the filter. The law also defines internal energy of system and instantive property for taking account of the balance of heat or work in the system. Energy cannot be created or be transferred, but it also be transformed into one form to another in an isolated system. The sum of all form of energy is constant. An equivalent statement in the perpetual motion machine of the first kind of impossible work done by a system on its surrounding requires that the system internal energy be consumed, so that the amount of internal energy lost by that work must be resupplied as heat by external energy source or work as work by an external machine acting on system sustain the work of the system continuous. The ideal accelerated system of which the entire universe is an example is often only used as a model. Many systems in practical application require the consideration of internal chemical or nuclear reaction, as well as transfer of matter into or out of the system. For such consideration, thermodynamics also define the concept of open system, closed system, and other types. So that's from me. Then we move to the next slide.
My name is Firda Halil. I'm from RY31. In thermodynamics, heat is the thermal energy transferred between systems due to a temperature difference. Heat sometimes refers to thermal energy itself. Thermal energy is the kinetic energy of vibrating and colliding atoms in a substance. Next, thermodynamic work. Thermodynamic work is one of the principal processes by which a thermodynamic system it can interact with its surrounding and exchange energy. This exchange results in externally measurable macroscopic force on the system surrounding, which can cause mechanical work. To lift a weight, for example, cause change in electromagnetic or gravitational variable. The surroundings also can perform on a thermodynamic system, which is measured by opposite sign convention.
The internal energy of a thermodynamic system is the energy contained within it, measured as the quantity of energy necessary to bring the system from its standard internal state to its present internal state of interest, accounting for the gains and loss of energy due to change in its internal state, including such quantities as magnetization. It includes the kinetic energy of motion of the system as a whole and the potential energy of position of the system as with respect to its surrounding and internal force field. It includes the terminal energy. As example, the constituent particle kinetic energies of motion relative to the motion of the system as a whole. The internal energy of an isolated system cannot change as expressed in the law of The internal energy of an isolated system cannot change as expressed in the law of conservation of energy, a foundation of the first law of thermodynamics.
Assalamualaikum and good evening. My name is Shahrul. Today I want to discuss about the conservation of energy. The law of conservation of energy states that the total energy of an isolated system remains constant. It is said to be conserved over time. In the case of the closed system, the principle said that the total amount of energy within the system can only be changed through energy entering or leaving the system. Energy can neither be created nor destroyed. Rather, it can only be transformed to the transfer from one to another. For instance, chemical energy is converted to kinetic energy when a stick of dynamite explodes. If one adds up all forms of the kinetic that were released in the explosion, such as the kinetic energy and potential energy of the piece as well as heat and sound, one will get the exact degrees of chemical energy is combustion of the dynamite. Thermal equilibrium. Two physical systems are in thermal equilibrium if there is not net flow of thermal energy between them. When they are connected by a patch permeable to heat. Thermal equilibrium obeys the zeroth law of thermodynamics. A system is said to be in thermal equilibrium with itself if the temperature within the system is partially uniform and temporally constant. System and thermodynamic equilibrium are always in thermal equilibrium, but the converse is not always true. If the connection between the system allows transfer of energy, as change its internal energy, but does not allow transfer of matter or transfer of energy as work. The two systems may reach thermal equilibrium without reaching thermodynamic and equilibrium. Conclusion. The first law of thermodynamics states that energy can neither be created nor destroyed, only altered in form. It is a fundamental principle that describes the conservation of energy in a system, emphasizing the balance between energy transfer and the internal energy of the system. The law distinguishes between various forms of energy transfer, such as heat and thermodynamic work, and it is of great importance in understanding the behavior of energy in different processes. In summary, the first law of thermodynamics is a cornerstone principle that governs the conservation of energy in thermodynamic systems.